You are really welcome here in this continuous cover forest experiment. My name is Yrjö Nuutinen. I'm senior scientist from Yrjö and little bit myself. More or less, I have done my whole work career in implementing this harvester work and forwarder work. By other words, from stump to the roadside storage. And that's the only thing I more or less know. I don't know anything about anymore, and it's enough for me. And now we have really good weather here. This in nice Finnish cold spring wind from northeast for many weeks. And this experimental area where we are now is concentrating really in this implementing of continuous cover forestry. Shall I, Evgeny, tell about continuous cover forestry, the management there? Well, continuous cover forestry is forest management method which doesn't, the aim is that it never ends up to the clear cutting. It is shortly that. And there, how we will do it, what kind of forest we leave after cutting, it depends in many things. The starting situation, so is it peatland, mineral soil land, age of the forest, about the stand structure of the forest before cutting. And we have in Finland, we have really excellent these forest management recommendations. So here we are not doing research and development for the forest management itself, but the implementing. And in implementing is first important is the pre-planning. First is how we find the forest. And there we have these digitalization methods, remote sensing, drone mapping, and even these traditional maps and walking in the forest. Secondly, there is then second stage is when the pre-planning is done, then the harvester operator and harvester comes into forest. Then we need to develop different kind of tools for implementing that work. For example, there is the aim which we are reaching at in the future, that there's really, we have in the harvester cabin is monitor, and we have visual map for the forest during the cutting. Operator sees the trees there in monitor, and naturally he sees from cabin the real forest, but in the monitor is shown up that which trees to be removed and for example strip road planning and so on. And why is that important? The reason for that is that for example, this experiment is in peatlands, and then in peatland is important the groundwater level. So if we cut too heavily, the water level goes up, and that is not for the good for the forest. And if it's done not enough, then the level goes down, and then it's that also not good. And then also then what is the influence for the growth and so on. And this for you are concentrating, if I understood right, this forest carbon things. And then forest management is important, but also when we are trying to get new methods for this management, and overall when we are thinking about forest management conducting, the first that we in Finland, now I talk about only in Finland, that if we want that new method, we will get that in the real work, it must be cost effective. It must bring something that we can get the cost down. Otherwise, I speak now quite straight, but honestly, that there's no hope to get anything. It's not really good possibility to get anything, because we are in Finland, we are living from the forest. We have these professionals, forest contractors are most important. They are working accurate work, and they are paid for this cut. When you see these trees, what is cut, then when the trees are cut and transported to the roadside storage, then is the time to get the salary. So that's the reason. What's then? That was the background. So continuous cover story, no clear cutting. And in this experiment, should you come little bit closer, or I could show this is experimental arrangement.
So maybe explain that. What are the ideal conditions when continuous cover forestry is an attractive alternative, and when it's not?
Well, yes, it's a big question, and who knows? But at least what is for sure that this is partly now my own opinions, and based on my experience and also research what I have possibly done, that the most important thing is we can implement continuous cover forestry wherever we want to. It's not a problem. But then what happens after that? That is a good question. That most important thing when we go to there, we see that there must be good possibility that we will get the new growth. So new seedlings come up. So whatever the place is, mineral soil or peatlands, the best places are so that they are regenerating naturally well. That is the answer. But then there's also the truth of moment is the conducting. We have, where is Teemu here? Where's Teemu? Our contractor. We have the contractor who did it here. He's somewhere here. But the truth moment is then the implementing, when we are really do the real work. And we can have good plans, recommendations, but if we have a good machine and good skillful operator, we don't have everything can be spoiled in 1 week. That's the truth. Yes, but if we can look now this here. You have the. You don't have the map. You have the map. Well, I saw here. We are now here, and then we have 3 different monitoring stands, and they are the starting situation. The stand structure is different in each stand, and now we are here. The first stand is called. Wait a minute. This is now This is like a selective cutting stand. So here is the stand structure has been before cutting uneven. There has been big trees, small trees, and the seedlings have been regenerated quite well. So that is that, and then here you can see is there are only 3 plots. It is called first thinning stand. There that is just spruce, planted spruce stand about 40-50 years old, and there has been done this a certain thinning treatment I will explain the treatments then. And the third stand beside the railway station there, half a kilometer in that direction, is clear cutting stand. So it's called clear cutting stand that it's enough old and there's enough cubic meters per hectare that if we want, we could do their clear cutting. But we don't, it's not done. Everything is here, the treatments are aimed for continuous cover forestry. And then next we could look these treatments. So each stand has same treatments. So the red is here, this zone thinning. Have you this here? We will look that in the forest, the zone thinning method. So it's kind of transformation cutting, reaching the continuous cover forestry. Is it, Evgeny? It goes right. Yeah, that I don't explain too much. Then second treatment is traditional selective thinning below the yellow one, and it is as it's the most common in Finland, and it ends up always in clear cutting sooner or later. So we do 2-3 thinnings, selective thinning below thinnings, and then is clear cutting. And why is that? Because we are now, this is developmental research study stand, so we need to have the control. So, and this is work study, so not forest management, but implementing this work study, how productivity is and how the harvester work goes and so on. And then the last treatment is then the red one, continuous cover forestry. The green one here, it is selective cutting. So meaning that it's the usual method, and this. So we take mostly the big trees which don't grow anymore and give space for the smaller trees and for the natural regeneration. These were the treatments. So this, what about this zone thinning, the red one is totally new method. So this has been, and there is our very important partner is UPM Forestry here, and this forest is UPM Forestry stand. So shortly, what has been done in these experiments, this first was there is with UPM. Here is Tero Anttila, here UPM forest management leader. So first one, we looked at these stands. Then we placed the plots here, and then Evgeny came here and did this drone mapping before cutting. Then here's Arbonaut remote sensing company always is also here with us. So we have this remote sensing data before cutting. Then Evgeny's drone mapping after cutting, and then we have there's Ville and Tapio, our research engineers who have manually mapped and measured each tree and the seedlings here. And then the work study, so harvester productivity data from the harvester computer and video recording of the cutting and what else. After cutting, työmittaisesti korjuuvauriot, stem damages, they have measured and everything. So we have heavy data here.